Hello, I'm Lance Campo, part of the marketing department here at Clean Air Industries. I'd like to thank everybody who's attending our webinar today, Air Filtration Strategies for Powder Coating and Painting Operations. This is part of a recurring series of webinars that's being hosted by Clean Air Industries, covering topics such as the kind of problems we encounter in the field of air pollution control for manufacturing and the types of solutions and equipment that are available to help improve air quality more efficiently. Our webinar today will feature our guest speakers, Trey Peavy and Chris Schock from RTT, formerly known as Colmet. They'll talk a little bit about the business and more specifically about the applications and equipments that they serve. And we're really happy and proud to have RTT as part of the Clean Air Industries family. I've visited the facility. It's a nice modern facility, very efficient and impressive in my opinion. So I just wanted to put that in there. I'd like to remind all of our guests that we do have a question and answer function. So if you'd like to submit your questions, you can using the question and answer function in your the webinar window. It's Q&A. Submit your questions by text, and then we will be having a session to answer your questions at the end. I'll be popping on and off to remind you guys to do that a little bit. I also just like to remind everybody that as part of a recurring series of webinars, we will also host a webinar on Wednesday, October 22nd, titled The Hidden Hazard, How to Tackle Oil Mist and Smoke for a Safer Workplace. That'll be at 4 p.m. And we'll be sending you some information after this webinar to remind you to help to sign up for that and join us again in October. So without further ado, I'd like to introduce the first of our guests, Trey Peavy. I'd invite him to take screen control, and he'll be able to share his information. And thank you very much.
All right. Yeah. Thank you, Lance, for that introduction. I'm trusting that everyone can see our opening slide here. I'd just like to take a moment as well to thank everyone for taking a little bit of time out of their day to join us in the webinar, and just to kind of give a little quick rundown of who I am and a little bit of rundown of who Chris Schock is. That'll be taking on the second part of the presentation here. So RTT has been in the industry now since about 1996, 1997. So we're almost 30 years in the industry. We started out as a company called Colmet Spray Booths, have rebranded a couple different times and a couple different runarounds. And in May, we joined the Clean Air Industries family, and we're glad to be a part of these series of webinars and as well as a part of Clean Air Industries. And I'm the general manager here at RTT. I moved over from the sales side of our company, and after the acquisition, moved into more of an operational role as the general manager for here in Rockwall, Texas for RTT. Chris Schock is a longtime regional manager for us. He may go into a little bit of his own introduction, so I don't want to steal that from you guys, but he's been about, I think, probably around 14, 15, 16 years, somewhere around in there with RTT, has worked in an outside capacity there, and it's a very pivotal part of our organization and just a breadth of knowledge in these topics. So kind of just to get going here, we're going to kind of jump right into the meat of it all. We're going to talk a little bit about powder coating and some of the equipment that RTT offers in powder booths. When we speak of powder coating, there's a lot that goes into that. There's pre-treatment, there's the booths themselves, there's dry ovens and cure ovens and different processes to do those. But in this webinar, I'm going to tease you a little bit and just keep you on one topic, and that's just going to be powder booths. And I'm sure we'll have some coming up down the road that'll discuss other components, part of that process. So don't know who's on the call here, so let's just kind of start from the beginning, right? What is powder coat? Powder coating is a dry finishing process, right? So it's opposite of liquid spray. It's a dry finishing product that was brought in to North America in the 60s. It's estimated that powder coating is about 20% of the industrial market. It's growing. A lot of the powder manufacturers are crossing over into different types of substrates. You're seeing some powder coating for woods and things like that didn't exist 10 years ago, or if it didn't really work out very well. So that I'm sure that number is going to start to grow and take over. There's a lot of advantages to powder coating systems when it comes to air handling and air movement and safety of your personnel. We'll talk through that a little bit in our presentation. But if you don't know what that is for a powder, it's just a polymer resin that's been brought in to mix with other additives, and they kind of melt that, grind it up, and then it's in powder form to be sprayed. And then as it's heated back up, it begins to melt back again, cross-link, and join to the substrate. And that's usually done through an electrostatic spray process, for the gun. So you have a charged particle and a grounded product, and you can coat the backside of a product from spraying it from one side. And that was one thing that powder coating had an advantage over liquid for a while. Now that technology is there as far as liquid as well. So kind of to move through, just talk about some of the booths here that RTT offers. It's some standard powder designs. We call it a PB, which really is very sophisticated for powder booth. And that's just a batch powder booth. And that's the one that you see in the top left corner in the images. That's just a basic open front design, no reclaim collection. It uses a 3-stage filtration with a polyester blanket, a polyester cube or bag filter, and then finally redundant filtration for the air that's being turned back in. RPCs and RPBs for us are booths that are using collector units in the back that can be reclaimed. They can still also be sprayed to waste, but we have regenerative cartridge filters that are being reverse pulsed in those scenarios. So you offer a little bit more functionality in those booths. And then we have an EPB style of booth, which would be a pass-through style, that bottom left corner. This is for usually higher production environments where you have a process line of parts that are running continuously through there. The adding of automatic reciprocating guns is where you see this in this type of booth a lot of times. So let's get into kind of some of the design of those booths and what's happening. And in a powder coating booth, it's different from a booth that works inside of a liquid spray environment. Is we're able to take the air from the environment and put it back into the same environment. So the need for air handling equipment, air replacement goes away in majority of powder coating systems because of this type of technology. There's no VOC that's in the air. No volatile organic compounds are going to contaminate the airstream. So as long as we can filter out the dry particulate that's the powder itself, then we can return that air back into the working environment safely for personnel and other operations. So that's how the airflow would move into a booth like this. And we see in the presentation here, the air would go in through the working area, flow through in these examples, either into the filter bank or into the collector units, and then return on the backside of that initial filtration through redundant filtration back into the environment. To look at how we would calculate airflow. Airflow is very important, for any type of spraying application, and for powder especially. If we think of the batch system there on the right-hand side, if we take a standard smaller powder booth, then what we would target as a manufacturer would be air movement somewhere around 85 feet per minute. Now, it is very likely that airflows can be higher than that. We've settled as a standard without knowing a lot about the process or the parts or the application style, and said that 85% satisfies a couple of things. It has enough airflow to migrate powder in air back towards the filtration system. It also allows for a nice first pass transfer efficiency of your powder guns. If you have too much airflow in your powder gun is spraying out, it's dragging before it gets to the part potentially, right? So you could potentially take powder that's in the air and drag it beyond the product that's being coated into the filtration system, which would not be a good representation of a first pass transfer efficiency, especially if you're planning to spray to waste, which we'll talk about some of that here in a little bit. But that can become detrimental to the system design there. But when we look over on the left-hand side and we see a higher production environment, a conveyorized system, the pass-through, even in another style of booth, but in a higher production environment, we began to look at those a little differently. And we say that we want to target a higher CFM, some 20 to 50% more in some cases. And the airflow is always calculated based on how many openings are in those booths. And you'll see in the industry a booth that powder is migrating away from the booth, and a lot of times that happens in a conveyor system because of the automatic guns that are in there. A lot of powder is being discharged into that booth, and that booth needs to have a little bit higher of an air volume and a velocity through the booth to ensure that powder is being drawn back towards the collection system. So when we build booths that way, we are looking for a little bit more of airflow there. And again, it's always about the part. It's always about the application process. And that's how we would really nail down a final design when we work through these things. So that in that particular solution, we're moving and designing the booth as it should be. When we think of cartridge collectors, right? I mean, a spray to waste powder booth that has a filtration system on the back, it's impossible to reclaim that powder. But with collection units, it gives us the ability to make that choice. We actually have three choices with a collector unit. We can spray to waste, we can manually reclaim that powder, or we can automatically reclaim that powder. So there's a couple of variations of collector units that we use kind of out of the box for us. An RPC collector, which is just a reclaimed powder collector, if you want to get into the nomenclature, and an RPC slimline. And what these collectors are is they're in essence very similar to each other, but they're designed to be in different applications where square footage is possibly an issue, or even with some of our newer designs that we run in a high production environment and we want to auto reclaim the powder that's being captured. And when we do those, we use certain style of collectors on those. So we'll just kind of run through some of the features of those here real quick with everyone. This is an RPC collector. This is kind of a standard. When you start out, this is what we're looking at. And you'll notice in the picture to the right there that that collector looks like it has drawers in the bottom of it. And it does. And that can be used in a spray to waste design. That can be used in a manual reclaim design, and those can be used in an auto reclaim design. The only difference between a drawer and something that we need to fluidize so that we can auto reclaim it would be a fluidizing pan that's in the bottom of that drawer design. So for us, if you have an RPC collector and you're using it in a spray to waste, or you're having to vacuum out from the drawers, you could go to a fluidizing system that would fluidize the powder so that you could automatically transfer it back with a transfer pump back to a sieve or hopper. So some of the features that we're looking at with the RPCs they are all welded out of 10 gauge steel, and they're powder coated white. These things are not small. They're not rattling around. They're not going to tin can. As they're running, they're quite well built. When we build powder collectors, we use VFDs to control the speed of the direct drive reverse incline fan. And you'll see some other folks in the industry that'll use dampers. And what they're really doing is they're just increasing the initial resistance that the fan sees through the damper system so that it's not as efficient. We choose to be more efficient than that and spin the fan at the RPM that's required. And we do that through a VFD. And it also offers the ability for us to have multi-speed units so that the unit can run at one speed during the application process and can be potentially sped up during a clean down process. You have the compressed reverse system. That's those units on the very top of that unit. Those are back feeding the filtration with compressed air and a pulse system as that filter loading reaches a certain point or a time interval has been selected in the control system. Those will pulse down to keep those filters running longer. A cartridge filter in a properly maintained system should see at least a year in production. depending on, I mean, the production levels, those can always change, but that's the time frame you would kind of look for something like that. We mentioned a little bit spray to waste or reclaim designs are capable of these things. The 80/20 filters are cellulose filters are what comes standard in an RPC. We do have other technology of filters with higher efficiencies or some nanotechnologies and things like that that can always be brought in into special environments when needed. The redundant filtration, if you've seen some of our powder collectors in the past, we have recently changed these filters over to a Villadon MV75 expanded media filter. We really like the performance of these filters here. And we really, if you've ever seen the other version that we use, the metal encased, really more of a high temperature type filter, is that they can burst. And if somebody has decided to clean off their compressed or their cartridge filters with an air nozzle and 120 psi, to blow their filters off, and then they rip the cartridge filter, it doesn't take long to load these up with powder. The MV75 can handle like 22 inches before it bursts. So we really like that ability there that keeps the environment a lot safer if something did happen in the system, for personnel. The RPC slimline collector is very similar in its features. It's just constructed a little differently. The air discharge is put on top of the unit. It's a narrower design than the RPC collector. It's still powder coated. It's still VFD controlled, and it's designed out of a mixture of materials. The fan plenum itself is designed out of 10 gauge. So that heavier material is still there where the fan is and all the turbulent air, and the 14 gauge shell is down below that houses the filtration. You still see the trays or the drawer there in the bottom, which can be used for the spray to waste or a reclaim design. When you looking at these, the slimline collector for a large booth, a high volume booth that isn't a pass through with an elevated floor, we've developed a slimline that has a subgrade fluidization bed. It's a single bed, which if you've seen some of our other units, there's 2, sometimes 3 beds in the bottom of a collector. It's been redesigned to go to a single bed to be able to transfer the powder automatically back out of that system. As you see in the image there in the center, you have one transfer pump that's pulling from that entire collector. The last style of collector that we have would be like a wedge or a roll-off style. And these are, specifically designed for the elevated floor pass-through designs. And the wedge collector itself is designed to be easily rolled off and owned straight in and straight out. And you would have different collectors for different colors. We have changed the design of a traditional roll-off and went with a vertical twist lock cartridge design. Instead of the horizontal, we feel like this gives a better anti-loading of the filters as they pulse, as powder trickles out of the system. It's not falling and setting on top of another filter, blinding out the top portion of that filter. The fan plenum, similar to the slimline design, sets above the wedge collector. And the reason why it's called a wedge is the front side of the collector is shorter than the back side on an angle. So the tighter that it becomes to the booth, the tighter it seals itself to the fan plenum, which makes it really nice for pulling off and on. Unlevel floor surfaces become less of an issue because our mating surfaces aren't 90 degrees to each other, as you would see in a traditional roll-away fan plenum design. And these are limited in sizes, and mostly they go larger than our standard roll-off design. And we're looking around 7,000 to 12,000 CFM out of these units. And in custom environments, very similar to all of the renderings there that you see, it's possible that multiple collector units are required to move that required 100 to 125 feet per minute of air through a system like this. There is fluidation in the bottom of these units as a standard, and they're used to capture the powder there in the bottom and are fluidized for auto reclaim of that powder. Similar to the RPC slim lines, they're made out of multiple pieces of material, but really nothing smaller than 14 gauge. 10 gauge is by far the material thickness of choice, and they're all powder coated white as well. And again, just to reiterate that these are designed to be on an elevated floor basement. If they were to be implemented in a booth that was setting at floor level, there would need to be a pit subgrade that the collector units and the fan plenum would set in, and roll away from there. And that is my portion of the presentation. And I appreciate everyone's time and look forward to answering questions here in a couple of minutes.
Thank you very much, Trey. Very interesting. I'm taking some notes as we're listening here. I just wanted to remind everybody that's viewing our webinar to, if you could submit your questions, if you have a question you'd like to ask, please submit it in writing using the question and answer function in the chat window. We'll be more than happy to get that to our hosts at the end. We're going to have a question period of about 15 minutes or so, and I will be back to help with that. And at this time, I'd like to introduce Chris Schock to take over, and he'll be doing his presentation. Chris?
Okay, appreciate the intro there. Are you guys, first off, are you guys able to see my screen, I'm hoping?
I do.
Perfect. We'll start with there, and I was actually hoping Trey was going to talk a little bit longer. This might be a moment of history when he was actually short. But with all that being said, appreciate again everybody jumping on. My position at RTT has been an outside sales manager. So with that, I get the privilege of going out and seeing how all this equipment works in the real world. And on paper, you guys just saw a lot of squares, a lot of booths. It looks very simple as you're kind of looking at it as is, but the real world always kind of throws a curveball at you. So I know I see a lot of familiar names and I see a lot of new names. So if you're new to this and understanding some of these product lines that now our Clean Air partners are providing, I want to give you a quick crash course into what some of the liquid side is. Trey did a really good technical job on the powder, and he also explained that the powder it's a smaller portion of our industry, but it's growing, and it's growing for a lot of good reasons. But really, I'd say 80% of our industry is still industrial liquid coating equipment. And with that, I'm going to try to give you guys my quick, call it infomercial on what our capabilities are and really what to look for to kick off and how to sell a booth and pretty quickly here. So to kind of get going, if you're not familiar, what does a spray booth actually do? And similar to a powder booth, it confines that hazardous material, and ultimately it's going to prevent fire and explosion, right? It makes it a safer working environment, especially when you're atomizing like a solvent or a harmful chemical. The other action of the spray booth is going to be able to control that overspray really through airflow management. Similar to how that dust particulate is conveyed, that atomized liquid is going to be conveyed through that air movement as well into the filtration system. And of course, it's not just about keeping those hazardous VOCs inside that working area. It's keeping the dirt, the dust, the debris from getting into that, causing rework, causing defects, items like that. So every booth essentially has the same components. You've got an enclosure. And when you look at NFPA and OSHA, you need a compliant enclosure that's smooth interior surface. And ideally, that's going to be made from almost every spray booth I know is 18 gauge galvanized, unless it's a special circumstance for stainless or something like that. But with that, you're also going to have the appropriate lighting in there. So now you've got a confined area with adequate work lighting and airflow. And a booth needs a lot of air. Trey got into some of the technicals in terms of how to size airflow for a booth. For a typical cross wrap that I'll show you in a second, you want 100 linear feet per minute of air movement. So a booth that's 10 wide by 8 tall is 8,000 cubic feet per minute of air, and that'll exhaust a facility pretty quick. Filtration. For my guys who sell filters out there, obviously this is probably, everyone's laughing a little bit, but this is a vital component to that booth, and it's usually overlooked. And of course, the exhaust. The big difference between a liquid booth versus a powder booth is it the liquid booth needs to exhaust outside. And with that, with all that type of air movement, if you're in an area that's an air conditioned shop or a heated facility, obviously blowing all that outside is a bit of a challenge. So to give you a quick background into our product lines, we've got a lot of standard industrial equipment. And you can see in the upper left, that's the exhaust plenum. That's really sort of the heart of the booth that houses the filtration, and it also houses the fan and ductwork. And with that, that's really what creates the draw. Now, if you add two vertical walls and a ceiling, you now have an open front enclosed industrial booth. Now, to take it one step further, you can add a set of filter doors on there. And those filter doors, again, will help prevent any contamination from getting in there. You can pressurize an enclosed booth if you add solid doors. And I'll get to some of those customization steps here in just a little bit. But I wanted to point out that if you get a chance to look at our sales literature, our standard booths can ship in about 10 business days. So once you get to a little bit more of a custom solution here, if say your production is increasing and you need to be able to push it in one side and then out the back. So with that, you would do what we call a bridge plenum or a pant leg plenum. You can see how it looks like a tower here. And as it goes into the booth, this is now a larger truck booth that has a drive-through configuration and just one fan. So with that, you can increase production with the process flow, especially with larger parts. The fun part about it is when you get to the real world is you're turning corners, moving stuff around, and ultimately trying to figure out how to move that stuff in and out. One downside on this is you've obviously have that external bridge plenum, which takes up just over 2 feet of additional height. Now, if you guys are looking to sell equipment, most of your customers are probably trying to put a 10-foot tall booth into an 11-foot tall room. So how do you get around that? Well, we could do custom exhaust towers, and you can see where there's a split there. We now have two towers, two fans to maximize that internal working height, to maximize that door height and or width. So all fun stuff to take a look at. And again, doors and process flow are usually a really big challenge with the liquid side of booths. So now that you guys have gotten about 4 minutes of a crash course on how to sell liquid equipment, you're almost experts. So bear with me here. It comes to really designing a solution. And if you look at the pictures I'm showing here, here's just some notable projects that RTT has worked through to really develop a solution that's out of the box. You can see an offshore oil rig there to your left, and then there in the center, that's some of its components and how they're moving it in, what it's going to look like during that processing. To the lower right corner, you can see you've got an oven. The fun part of getting into powder coating is you got to cure it. So it's easy to get a booth, but then you've got to figure out how big of a cure area you're going to have, how are those parts going to go in and move. And these are all things that RTT is happy to help sit down and help you design to keep it moving. So how do you start? You've got a customer, he's got a part, he needs to paint it. And then you show up and it looks like this. It's about 30,000 pounds and it's moved with an overhead crane. All right. So it's a little bit more involved in an open front booth. And then you really start looking, well, where's it going to go? Trey really hit down and hammered on the really the fundamentals. It always comes down to the part. You got to look and see what they're doing. Are they racking them? Are they moving it with an overhead crane? What exactly are they going to be doing and how are they going to be doing it and where? So now that you've got an idea, okay, that's my biggest worst case scenario part. They're going to move it with an overhead crane. Here's where they're currently painting. They got big parts and small parts. Let's take a look at the facility. Okay, when you're standing outside, you got a dirt parking lot. You've got a roof that's pretty sloped. You got some old equipment up top, some grass and some basically scrap metal outside. So these are the challenges everybody's going to be tasked with while in the field. So, okay, now you're starting to build this thing out. Let's find where a spot is to put this process and where it's going to go. What I always tell people is when you walk into a facility, just look up. The first thing you need to do is look at that roof, see what obstructions there are, see if there's an overhead crane like there is in this situation. Is there also ductwork blowing air in and blowing AC? Could that affect the overall process? Especially in the powder coating world, that could be a big headache. Then, now you know roughly where it's going to go. Start just putting together a concept and a drawing. So projects, always require good communication and really to try to understand what's going on. Our inside team at RTT is always happy to work with you to come up with a drawing and really just start to design overall around that part and then for that facility as well. Um, Going back to my position as an RSM, there's three other counterparts that travel the country, and we're always happy to help you go out as needed as well. If you guys have an opportunity that needs another set of eyes, and whether you're proficient at SolidWorks, CAD, want to send a picture or a text message, or even on the back of a cocktail napkin, if you can get us a drawing of what it is you're trying to explain, we'll take it, and we'll work with you on that. Obviously, if you have the ability to get some facility drawings to get an idea of where it's going to go and what those obstructions are, that's always a huge help as well. But going back to that area you just saw in that back of the napkin sketch, here's what we call one of our approval drawings. This is an engineer drawing that's laid out. If you're not 100% sure what you're looking at, there's a lot going on here. But essentially, this is a pressurized enclosed booth that's got a crane slot in it. And also the ductwork is designed to go out the facility, not hit any obstructions, and to, again, make it minimally invasive for that installation. So this approval drawing essentially is going to show you guys where every light is, where every door swing is, and that's really what will help you refine the process when in the field. And of course, there's going to be more drawings to that with more modeling so you can see how it goes together. And then with that, you guys just took a customer from this to that. And with that, I wanted to keep it relatively short and sweet, just to give you guys a crash course into who we are and what we're doing. And yeah, I think that's, I'll stop it right there for now, and I'll turn it back over to Lance.
A very clear explanation of the process. I love watching these kind of presentations, guys. I'm really learning. I've been in the business for about 15 years, but I'm more related to fume extraction and dust collection from welding and grinding and things like that. So I'm learning a lot. I'm assuming some of our viewers are as well. So I did have a couple of questions. As we're waiting for some questions to come in, I invite people to submit your questions, please, using the question and answer function by text, and then I will read those questions to our hosts. And I have a couple of things I wanted to start off with. Chris, I'll start with you because you just presented. For some of the for the booths that have 10 business day lead time, could you just give me a bit more of a heads up as what kind of sizes you can get out of that situation? Because I think that could be something that our sales guys and our distributors would be really interested to know more about.
Absolutely. So many people are going to get the opportunity to quote a booth because their fire marshal came in and said, hey, you basically have to stop production. So we recognize the time to market is pretty vital to be able to do that. So when you're looking at our open front industrial booths and our enclosed industrial booths that are non-pressurized, really we keep it even numbers. So something like 6 feet wide, 8 feet wide, up to 20 feet wide and 12 feet tall. Those are really our standard metrics for that. We've also standardized extensions, so you can add additional depth to that without having to go through, an engineering process. By having those standard extensions and those standard models, time to market is so much faster, and the price point, obviously being pre-engineered, just makes it that much more competitive on the market. If you're looking at something that's over 20 feet wide, of course we can do it. We're happy to. That becomes custom, mainly because we have to upgrade the steel support structure. But yeah, essentially those are sort of the magic numbers to keep it within. And I think in theory we'd make it 3 miles long if you needed with standard extensions, but obviously we would take a little bit more caution to that and looking at the airflow if it's going to be that long. But
something else you mentioned was that for the liquid, the spray process, you can exhaust to the outside of a facility. Is that typical?
That is absolutely typical. that's really the big difference too between powder and liquid. Those harmful VOCs, even if it's a waterborne, I still haven't really seen a fire marshal allow anything to go back into the facility. There are special systems out there to mitigate emission levels, such as like an RTO system or items like that. A lot of those are super costly. There is
That
special
that
filtration.
that's
Go
what I was
ahead.
going to ask because I assumed that for certain regional regulations, you might have to use chemical scrubbing of some sort
Chemical
as your.
scrubbing is absolutely, and that's, there's a few variations, but it's so process dependent. It's hard to say that. There was a booth that was being sold on the internet that was called the ductless booth, and even if you looked at the fine print, it said at least 10% needs to exhaust outside. So it's there's always got to be some termination outside to atmosphere for those exhaust fumes.
It makes sense. You can't just put the garbage outside. It has to be managed in some fashion at some point. You did also mention that the powder element is growing, but that industrial liquid coating equipment is still more popular. At this time, could you estimate about what percentage of sales you guys are doing between the two, powder versus liquid?
Ooh, that's a good question. I'm going to actually probably phone Trey in on this one. I'm going to take a stab too, but I'm going to say at least 85% is probably focused on liquid.
Okay. Trey, you're still on here? I got some questions for
I,
you.
I am. I am. If you think of powder as an entire industry, so if you think of the powder booths and the ovens associated with those powder booths, then I think the percentage is a little low for powder that Chris is giving. But it mostly just because of the higher price point that a powder curing oven requires, kind of skews those numbers. But in project wise, I agree with what Chris is saying there, and that's one of the advantages that liquid coating still maintains in the industry over powder is it doesn't have to be cured, right? If most of them can either be just flashed off after a little bit of time or a minimal amount of temperature to cure a liquid coating. A lot of the cure is done, with the chemistry that's in the coating itself, right? So with the solvents and things. So um, that's a lot of the reason why the liquid side is still predominant, and it is not limited to certain substrates as much as powder or our design, our floor space, and of the application environment and things like that.
Well, looking at the two different processes, you guys are clearly in touch with some of the applications and products that are typical. I mean, when I think of powder coating, I think of things like bicycle frames or structural steel and things that are basically being weatherized. Could you just sort of give me a preliminary as to some of the other applications or industries where these types of processes are seeing growth, is one question, and are good places to distribute and to sell?
That's seeing the growth in the powder coating market.
Either process, actually.
Yeah. So, I mean, in the powder, environment, a lot of times you've been limited by product size because of the size of the oven that's required to cure the coating, and just, sheer square footage of the plant that has to be used for that, right? So years ago, people said that you couldn't powder coat a trailer, and now probably the larger trailer manufacturers, at least 85% of the larger trailer manufacturers are powder coating trailers, right? So like it can be done. It's just that it has to be configured by us, right, or by someone. There's a lot of improvements in powder coating that's helping the industry out with a dust on dust environment where a primer can be sprayed and then a top coat be sprayed right on top of the uncured or non-gelled or soft cured primer. That's been probably a really big thing that's happened in the industry as far as the coating chemistry side that has helped drive a lot of products to powder coating, because the durability of the powder coating finish in most instances, outlasts the liquid coating durability, and the amount of mil thickness of a coating that you can apply, is drastically different when it comes to powder. Um, so, but like I say, a lot of a lot of technology is moving to the wood side. A lot of things that are moving that way, the metallics, uh, and a lot of that is happening on just the powder coatings themselves, right? I don't sell powder coating, so I'm not sure with everything
Right.
that's going on. But
Well, I
like
do.
in the equipment that we sell for powder, it can be the guy that's got a little hobby shop, like you said, and he's maybe doing motorcycle frames, or a guy that's doing wheels, for cars or trucks. All the way up to, we're actually working a project right now, not to give too much away, but it's for barges, right? So we're
Okay.
trying to figure out, can we powder coat barges?
I was going to say, for a marine environment, I could imagine it'd have to be a pretty thick coating.
Yeah.
I'd add another question relating to. So, is there a formula that you use for calculating the need for a reclaim system? Is that in terms of product volume or the equipment size, or is that part of the process of when you guys build and design systems and quotes? You have that discussion, or do clients typically know that they want to reclaim powder before they talk to you?
Yeah, a little bit of both. A lot of guys know just from prior experience. A lot of that math and calculation is sort of given by the application manufacturers or the powder coating providers themselves. I mean, we have some experience and some just know that if you're spraying, continuous, a single color, right, you would want to try to reclaim that powder, if you could. A lot of it just, again, depends on the application. If you're trying to spray a bunch of different colors in an environment, you don't have time to clean between batches. You don't really know how to space out, what part is going to be what color. Depending on the type of product it is, it becomes a little more tricky. So, but there is math to that, and I don't want to make myself sound unintelligent, so I'm not going to try to repeat it.
I got you. You mentioned about the wedge-styled collector that you could roll in and roll out of a booth. Does that sort of solve, just by observation, I'm guessing that helps to solve the problem of turnover between colors? Is that, was I on to that?
Yes, yeah. So the use of a collector like that is designed so that when you run multiple colors, you have a collector that you say you would spray black in, and then
Right.
you would only spray black, and you would roll that collector away from the booth. You would clean the booth down, clear out the guns. Some application guns clean themselves, but that all has to be cleaned out. And then if you went to white, you would roll your white collector into there, and you
Exactly.
would you would begin spraying that color.
Okay, I just wanted to make sure that that's what I was the gist of what you were saying, and I assumed as much. And so in my mind, I was thinking, is it just manufacturing facilities, or do you have customization places that would, like places that build custom metal fabrication, where they might have a need to do multiple colors? These wedge style collectors, can they be configured for smaller booths, or are they really only designed for some of the larger automated type systems?
No, most of the wedge designs are in a smaller profile, straight line process. That doesn't mean the parts have to be small. That just
Right.
means that they're not normally 10 or 12 feet wide in a booth like that. Now that booth could be designed to handle a part that large, but as a standard, they're normally set up with a limited profile opening, about 5 feet by 3 feet, in that type of setup.
Okay. Just like to remind all of our viewers here to submit your questions in using the question and answer function. We have a quiet bunch of people out here listening today, guys. So I'm doing most of the question answering. I hope this is interesting for our viewers. I wanted to touch again on, for powder booths in specific, you talked about feet per minute and airflow, and using a VFD. So when you attach a VFD to a powder booth, is the VFD using some sort of active monitoring? So like when the filters load up, the VFD will increase the speed to maintain that airflow rate, or is it mostly for energy savings, or depending on the opening of the booth? You know what I mean? Like, how is that VFD used in the design typically?
Sure. Typically, the VFD is used to set the RPM of the fan wheel because it is a direct drive setup. So there's no pulley system, no belt system, and that speed of that wheel sets our cubic feet per minute, right? So if we wanted to move 12,000 CFM, we know how fast that wheel has to spin,
I see.
and we use the VFD to set that speed. When you use direct drives, right, you can use motors in different position or different pole motors to get some different speeds. We choose a VFD for a lot of energy efficiency, to speed up, to slow down, to change speeds if we needed to go from the spray environment to a clean down environment. But as the filters load, what we use is the regenerative pulse system to kind of maintain the resistance through the filters, so that it's set up to the static pressure that we have calculated for the airflow. And then that way we kind of maintain a steady, even airflow through the life of the filter cycle.
Okay, one more question for Chris and for you, Trey, as well. Could you talk a little bit about any type of safety mitigation that's required for handling liquid VOC vapors or powders? What type of safety systems or processes or protocols are integrated into the design of these types of airflow projects?
Go ahead.
Yeah, I'll just give a quick one for the liquid. So every liquid booth we send is going to have an air solenoid valve. That's really one of the first sort of steps of safety. And with that, for example, if you're not moving air, essentially that solenoid valve will essentially trigger and not let you atomize paint. And that just kind of prevents you from increasing that LEL, lower explosion limit level, in terms of what that looks like. So that's really step one. There's other, depending on the booth, whether it's pressurized or not, like a booth with cure mode. Our cure modes, the air makeup unit's going to send a signal to turn the lights off, and because it also reduces that airflow and it makes it a not safe environment to atomize paint. So there's things like that just, it's somewhat of a safety lockout to prevent that.
I'm actually starting to get some questions here, guys. So let me just sift through this for you a little bit. First one here: is it legal to only have a two-stage filter on a powder booth? Can I combine exhaust stacks into one?
So that's a confusing question slightly. Maybe it's two questions. I
think you're right about that, Trey.
Yeah, so to combine two stacks into one, there's a lot of requirements against the NFPA, and when it comes to the fire safety of combining exhaust stacks from different applications. They have a lot of verbiage about that, and it's really kind of frowned upon. They do allow manifolding or combining of certain applications up to a certain CFM. I don't really know off the top of my head right now, but I can tell you as a general rule, it's really tough to get that through an authority having jurisdiction. So if you read code to AHJ, where you're trying to combine hazardous exhaust from liquid systems into one. Now, if it's one exhaust from the same booth, that's a little different. You need a fire shutter in the exhaust system, and that really applies more to the fire suppression regulations that go with that. But again, to answer code questions and legalities of things, it always boils down to first, the authority having jurisdiction, and then secondly, the national code standards. Can you read me the first part of that question again in regards to powder?
Yes, that might have been a separate question, but I'll read it again. Is it legal to only have a two-stage filter on a powder booth?
Right. So you can. The main thing that the NFPA says that for a powder booth is that the air returning back into the environment has to filter the particulate to a safe level. So as long as the filtration that's been chosen, that it does that, then you've satisfied what the code has required for that. Now, I will go into tell you this, that the NFPA does not go into defining what a safe level is. So you again fall subject to the authority having jurisdiction and just general safety. OSHA does go into a little more of what air quality would be into some of their standards, but off the top of my head right now, I do not know those answers.
Okay. And got one more here. Can any process that is sprayed be modified to powder coating instead?
So
I can imagine there'd be a lot of people out there thinking about retrofitting maybe current equipment. Is that something you would consider, or do you do?
If you're thinking of,
go ahead, Trey. No, go ahead, Trey.
If you're just talking about the application equipment or the enclosure, right, the booth itself and the air handling equipment, yes, you could take a booth that was designed for a spray booth and turn it into a spray to waste powder booth, but you would need to make some modifications, right? The filtration racks would probably need to be modified. All of the fans are probably undersized for the amount of static pressure that you would need to account for in the loading of the powder. And then you would, obviously we would recommend that you add some redundant filtration into that before you return that air back into the environment. All of that plays a factor against the fan system that was designed. So the static pressure would need to be adjusted in those instances. I would recommend against trying to jump from spray one shift and then go to powder the second shift. That's a little bit different a scenario that probably is not a good setup. But yeah, to convert a spray booth or a powder booth into a liquid can be done. A spray booth that has a cartridge collection system on it, I would urge that you replace that system with a more traditional, as Chris described, like an industrial chamber instead of a collector with filtration.
Okay. I have one more question relating to sort of a fire code, but I think I'm just going to pose the question and ask our viewer to take that question offline, just so you guys can get an idea of the type of questions that are being asked. Is there a solid fire code for a powder booth regarding having to have fire suppressant?
The NFPA 33 states that powder booths have to have fire suppression.
Okay. Pretty straightforward. Okay, I think that's going to do it for us, guys. Of course, if you'd like to visit us again for our next webinar, just wanted to remind everybody it's going to be October 22nd, and at 4 o'clock, it's going to be about oil mist and oil mist hazards, and we'll be sending you some follow-up information and hope you'll join us with that. I'd like to thank Trey and Chris today for taking time to meet with us, and for all of our guests for coming to sit with us and to learn a little bit about powder booths and spray booths, and I'm really happy that I had a chance to learn as well, guys, so I appreciate that a lot. And so until next time, I'd like to thank everybody for joining us, and be sure to check out our websites and come to visit us anytime with your questions. We'll be more than happy to help serve your needs in the future. Thanks again, everybody.